Okay, we're going to go over some of the most common compressors that we run into on a daily basis. So these are 3 compressors that we run into daily, and just go over some of the differences between the 3. So let's start with this compressor here. So it's sometimes called old style or conventional compressor. It runs on 120 volts, single phase, single speed. It's an off-on compressor. It has a start winding and a run winding. This compressor here is an inverter drive compressor. So it's a 230 volt, 3-phase, variable speed. So what this inverter does is it sends 230 volts to the compressor continuously, and then it cycles the hertz. So the hertz on this unit here can go anywhere from 53 hertz to 150 hertz, and it can change the speed of the compressor. One thing to keep in mind with these is this inverter information on this tag has to match the inverter information on the compressor. So don't mix those up and don't switch out other inverters. It may run, but it's not the way it's designed to run. And this here could make some people cringe. This is a linear compressor, 230 volts. It has 1 winding, and we'll go over the differences between the insides. So with this compressor here, the on-off compressor, single speed, it has a PTC relay, which actually will energize both the start and the run windings together. And once the amp draw starts to fall off, it'll actually take the start winding out of the equation. And when you're checking the windings on these, you'll see the configuration of the pins. It's 1 up, 2 down. So you'll have your common, and then you'll have your start, and then your run winding. And your start winding is always going to be higher than your run winding. So if you go from this pin to the top pin, you're going to get your 21.1 ohms, and from your common top pin to this pin, you're going to get 5.6 ohms. And then when you add those two together, you're going to get your 26.5 or thereabouts. On this 3-phase compressor, it's going to have 3 windings, and those 3 windings are all going to be equal, or they're going to be very close to equal. 0.1, 0.2 ohms difference is acceptable. Anything more than that, you may have a problem with the internal windings of the compressor. Again, this one is variable speed, so it cycles the hertz, changes the hertz, and that ramps the compressor up and slows the compressor down. A little bit more efficient. And then they come to the linear compressor, 1 winding. Usually on these, they're about 6.5 ohms, 230 volts. These 2 compressors are going to be very similar to this. They're going to have a rotating shaft and a piston. So they're going to turn this way and rotate this piston back and forth. And that's how they get the compression of the refrigerant. Now, on this unit, it's less moving parts, less friction. It's supposed to be more efficient, quieter. This pulses the piston back and forth this way. So this is a big coil. When that coil is energized, pulls the connecting rod this way and moves the piston back and forth. So it's energized, piston pulls forward, de-energized, the springs bring it back. So it's back and forth, back and forth, back and forth, versus these 2 compressors, which rotate. So when verifying any of the resistances on any of these compressors, refer to the manufacturer's specs to find out where your resistances are, because they could be off, but they could look like they're fine, but they may not be fine. And another test to do with these is make sure that none of your windings are going to ground. You may find that your winding readings are fine, but you need to go from one of your pins to the ground on the compressor, to the grounded side of the compressor. And so keep that in mind. And also, just because the windings measure out fine doesn't mean the compressor is good. There's other components in there that could fail that'll still show you that your windings are fine. You could have the valve at the top of the compressor, the discharge valve could be bad, so your suction pressure is going to be higher than normal because you're having bleed back out of the from the high side back into the compressor, and you're not able to pull down the low side like it should be. Another thing that could happen is you could have a seized compressor, and just because your windings read fine, the compressor could be seized. You could have high amp draw, and then you could be caused by a failed start component, whether it's a capacitor or whether it's the start component itself. So always double check everything and do the big picture diagnosis to be sure that you're diagnosing it properly, because you don't really necessarily want to do a compressor job if it's the start components that are causing it to fail and not the compressor itself.